Hi there, geometry students. This is Mrs. Hefty here, and we're still talking about triangles, and today we're going to focus on 5.3, which talks about inequalities in one triangle. We're going to talk about angles right now, and let's look at an exterior angle. The exterior angle theorem we have learned in a previous chapter. Angle 1 is an exterior angle because it is outside of the triangle when you extend one of the sides. Remember, the exterior angle equals the remote interior angles added together. So the measure of 1 equals the measure of angle 2 plus the measure of angle 3. And you'll need to draw this down and also write that information down underneath your exterior angle on your paper. Now, when we talk about inequalities, we're talking about greater than or less than or greater than and equal to and less than and equal to. I want to write an exterior inequality one right now. So I'm taking my exterior angle, which is angle 1, the measure of angle 1. Well, if 1 equals these two added together, and then I'm only looking at one of them, then 1 should be greater than each one of them by themselves. So the measure of angle 1 is greater than the measure of angle 2, and the measure of angle 1 is also greater than the measure of angle 3. All right, so let's take a look at our example problems that we have. It says use the exterior angle inequality theorem to list all angles that satisfy the condition. So in number 1, I am looking at angle 1, and I want angles that are less than 1. So I'm looking for things that are less than 1. That means 1 has to be the bigger angle. Well, the bigger angle is always the exterior angle. So I need to be looking at angle 1, and I need to have angle 1 be an exterior angle. So I'm looking at that triangle right there. The remote interior angles are the ones that are going to be smaller. So here's 1. So 5 is a remote interior and 6. So the measure of angle 5 and the measure of angle 6 are going to be the two that are going to be smaller than 1. Again, I want 1 to be the bigger angle, so I had to have 1 be on the outside. Let's take a look at number 2. I need measures that are greater than 5. All right, so if I'm looking for things that are greater than 5, I want 5 to be the smaller one. Okay, so if it's going to be the smaller one, it needs to be inside the triangle. So I'm looking at 5. So here I am. My 5's inside that triangle. I'm going to extend the side. So 1 would be the exterior angle. That would be the bigger one. So I'm looking at the measure of angle 1 be greater than 5. Now 5 is also part of another triangle. 3 and 5 together are part of this bigger triangle. And I extend it, and 7 is an outside angle. So 7 is also going to be greater than 5. Now, some people might be saying, well, what about these other angles? You can't tell people. You can only use the exterior angle inequality theorem. So each time I do these problems, I'm trying to draw a triangle, and I'm trying to draw an exterior angle. Let's look at number 3. I need measures less than 1. So 1 would have to be the bigger angle. 1 has to be the bigger angle. All right, so where should 1 be in relationship to the triangle if I want it to be the bigger angle? It would have to be on the outside. It would have to be the exterior angle. So I'm going to look for a triangle where 1's the exterior angle. And so I'm looking right here. Right? And so 1 is on the outside. So now the smaller ones are going to be the remote interior angles. So I'm looking at 7 and looking at that angle right there. Now that doesn't have a number, people, so you need to call it RPN. You could have called it RPS as well and gone all the way out to the S there. Now, since 5 and 4 are part of that, they are also going to be smaller than 1. So I'm going to write angle 4 and angle 5. Okay, now I can't, if people are looking at other ones and thinking, well, that's inside, but that's not part of that red triangle. I don't have 1, I need 1 to be an exterior angle. So this is the only triangle I can work with right now. So that might be going through some people's minds at this point. All right, let's take a look at our next relationships. Now we're going to look at our angles and our side relationships. And what it says is if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So if I draw a triangle, I make a obtuse angle, do you agree that this side here has the longest side? It's the longest side. And across from it then is going to be the biggest angle. And then when you have a really small angle, across from it is going to have the smallest side, is how that works. So when you have a big angle, the biggest side across is the biggest angle. When you have the smallest side across has the smallest angle. All right, so let's look over on the right-hand side then. It's asking us to list the angles from greatest to least. So what I'm doing is I'm looking for my biggest side. 48 is my biggest side. So across from it, we'll have the largest angle. This one will be the largest. So angle S is my largest angle. Then I need my next biggest one, which is 35 is the next biggest side. So across from it is going to be the next largest one. So R is going to be the middle one. 23 and 7/10 is the smallest, so across is going to be the smallest one then, angle T. The reverse works as well. If one angle of a triangle has a greater measure than another, then the side opposite of the greater angle is longer than the side opposite of the lesser angle. And I apologize, I didn't get all of that information down there, but you do have it on your paper. So what I'm saying here, guys, again, is if I have a really big angle, this is the largest angle, then across from that largest angle is going to be the largest side as well, or the longest side. And if you have a smaller angle across from, so let's just kind of summarize that. When you have the biggest angle, then across from it, you're going to have the biggest side. And same thing with the smallest angle, and across, you're going to have the smallest. Small side. So let's take a look at the one over on the right. It says list the sides from greatest to least. So I need the biggest side. Now just don't look and say, okay, AC looks like it's the longest one. You need to look and say, okay, 125 degrees is the biggest angle, so across from it is going to have the biggest side, AC. Then I'm looking and I'm saying, okay, what's my next biggest angle? 35. So across from it is going to be the next biggest side, which would be AB. And then 20 is my smallest angle, so across from it we'll have the smallest side, which is BC. All right, now we're asked to find the shortest segment. All right, now this time we have two triangles, people. So if you're looking at this and you're saying, okay, 50 is the smallest, so I say this is the smallest. That's not necessarily correct. You have two triangles that are stuck together here, people. So in this one, I have 55, so then across from that, this one is going to be the smallest. Not necessarily is BD going to be the smallest, people. Do you guys see here that in this green triangle, this is the smallest side. This line right here definitely is the smallest in the red triangle, but when I look at 60, 65, this one's going to be the largest one, and this would be the middle line. So when I look here, people, this line is not the smallest line. This line here is smaller than this one. So BC is the smallest segment in that whole entire figure. All right, let's take a look at number 5. It says list the triangle sides of the triangle MNO in order from longest to shortest. All right, so they're giving me expressions for my triangle. You guys don't have a ton of room, so you want to draw a picture. But draw a nice small one because I know I worked mine out on the paper and I needed a lot of room. They're giving me the angles here. I need to find the value of x is what I need to do. So m is 4x plus 20, n is 2x plus 10, and o is 3x minus 20. So to find the value of x, what I need to do first is write an equation. Those are all of the angles. So I'm going to add all of those angles up and I'm going to equal them to 180. So I'm taking 4x plus 20. I'm taking 2x plus 10. And I'm taking my 3x minus 20. And I'm equaling to 180. Next thing I'm going to do is I'm going to get my like terms together. That's going to give me 4 and 2 is 6 and 3 is 9x. 20 and 10 is 30 minus 20 is a positive 10. It's 180. Move my 10. I'm going to get 9x is 170. X equals, and so I'm going to get, when I divide that, I get 18 and 8/9. Now what I need to do is I need to find, and you guys are writing this all down, this is important, I need to find the measure of angle M. So I'm going to go 4, I'm going to take 18 and 8/9, I'm going to add 20 to it. Punch that in my calculator, 4 times 18 and 8/9 plus 20, and I get 95, I'm going to write it in my picture, and 5/9. Then I'm going to find the measure of angle N. I'm going to go 2 times 18 and 8/9 and plus 10. I'm going to punch that in my calculator and I'm going to get 47 and 7/9. And then I need to find the measure of angle O. So I'm going to take 3 times 18 and 8/9. I'm writing all of this down. This is important information. And I punch that in my calculator, and I get 36 and 2/3. Now before I move on, I am going to add these up to see that they add up to 180 degrees, and if they don't, then I have an error somewhere. They're asking me longest to smallest, longest. So I need the largest angle going across from it, NO. Then I need my next biggest one, 47 and 7/9, MO.
And that leaves me with